Should help you with the G3 tessellation and transformation standard. There's two parts to G3. One's distance, midpoint, slope, and the other is transformations, tessellations. This was chapter 9. We've covered it fairly quickly. There's a separate video on this on the same YouTube channel, so if you need to watch that, please do. I'm just going to cover a few things that I know that you guys tend to get confused. So we talked about some different transformations. First one is translation, which is a slide. You have a reflection, which is a flip, and you can reflect something across the X or Y axis. We also had a rotation, which is a turn. What else was there? Oh, we had a dilation, so to enlarge something. Okay, when you're reflecting something, there are these different rules. So if you reflect across the x-axis, x stays the same. And if you reflect something across the y-axis, y stays the same. And if you reflect across the line y equals x, the coordinate points will switch places. So let me give you some examples. Let's say we have the coordinate point for -2. Okay? If I take that coordinate point and reflect across x, then the new coordinate point will be, well, x stays the same, so it's 4, and then the y value changes signs. If I'm going to take that same point and now reflect it across y, it means y stays the same and x changes values. So I'm going to get 4, still -2. And if I reflect across the line y equals x, they're going to switch places. So it's 4, -2, now it's -2, 4. I know there was some confusion on what the line y equals x even is. So let me draw a coordinate plane here. Okay. The line y equals x is this line I'm drawing here in black. Okay? So when I have this point, I'm just going to kind of sketch each one of these. If I start out with the point over 4 down 2, and I reflect that across the the line y equals x, that's now going to be over 2 up 4. And you can see, I mean, I'm just sketching this, but how those are like pretty much, they should be exactly the same distance from that line, but this is just a sketch so you can see what happens. It's like you're folding it diagonally. If I reflect something across the y-axis, then here's my original point, then it should be the same distance from the y-axis. If I reflect across x, then it should be the same distance from x. Act like you're folding it. Some other things in this section were, we talked about tessellations. Basically, in order for you to tessellate something, it needs to, all the angles need to add up to 360 degrees. So for example, if we have a equilateral triangle, and I want to know, does this tessellate? And tessellation is a repeated pattern. What I would need to do is find one interior angle. So in this case, for an equilateral triangle, one interior angle would be 60. If you forget, or you have something like a pentagon or whatever octagon, you need to figure out the one interior angle. you can just use the formula 180 times n minus 2 divided by divided by n. That gives you one interior angle. Once you have your one interior angle, see if it divides nicely into 360. And it does. It goes in 6 times. If you get a decimal, it doesn't tessellate. If you get a whole number, it does tessellate. Okay, I think that's, well, actually, let's talk about, we didn't talk about symmetry. Line symmetry, I think you guys know what this is. So if you have like the letter E, okay, then you might have a line of symmetry going horizontally. It's kind of like related to when you're reflecting something across the x or y axis. You want to think about folding it. Point symmetry, I think this is what we tend to get confused on. Point symmetry is when you take an object, turn it around 180 degrees, and it still looks exactly the same. So let's say like a something like a square, and if I take that and turn it around 180 degrees, or even 360, you know, it's always going to look the same. Okay, so if you turn something 180 degrees and it looks exactly the same, then you're good. If you take, you know, think about like a heart, if I turn that around 180 degrees, it's not going to look the same. It's going to look like an upside down heart. So that does not have point symmetry. But it would have, you know, line symmetry as long as it was equal on both sides. Okay, I think that's it. So let me know if you have any questions. And like I said, that video for Chapter 9 is on the YouTube channel. Make sure you complete the worksheet, check your answers, and then take the little quiz on iTest.